All right, good morning, everyone. We're going to continue with our notes. This is page 8 in your Unit 9 packet. So yesterday, we explored how we can find the derivative uh, with parametric equations by breaking them into different components. So dy dx is just y prime over x prime, y with respect to time, and x with respect to time. Uh, So I think all that feels pretty intuitive. Uh, a lot of what we're going to do in this unit will feel familiar because we're just using a lot of what we've learned from first semester. It's really only when we get to polar graphs where it's going to feel uh, different. But when we talk about these next few sections in this unit, um, all the procedures will feel pretty familiar. Now, having said that, the second derivative for parametric equation, there's a little bit of adjustments in terms of what we need to do with this formula. So, to find the second derivative of a parametric equation, we first have to get into to find dy dx. So this is how we find dy dx, right? We find dy dt over dx dt, and that represents our kind of like our y prime. And so to get to the second derivative, we basically have to find the derivative of y prime. Uh, but the formula feels like there's an additional component that we're not expecting because we're going to find the derivative of dy dx, but really think of this as your y double prime here, or the derivative of your y prime. But then we still have to divide by dx dt. So this is the part that feels like it's not necessary, but this is really. But if we think of this as y prime, then we can think of it as, oh, I'm finding the derivative of y prime all over dx dt with respect to x. Okay, so let me highlight that part because this is the part that uh, feels like it is the part that we're going to have to remember as part of the formula. Okay, so number one, give the following parametric equations, or given the following parametric equations, find d2y over dx2 in terms of t. So first, let's get both x and y ready for the derivative. So let's say x is equal to t to the 1/2, and y is equal to 1/2 t squared minus 1. Okay, so x prime or dx dt is 1/2 t to the negative 1/2. Y prime is t. All right, bring down the 2 times 1/2. I'm just left with t. And then the 1 goes away to a 0, so just t. All right, so dy dx. Dy dx is just y prime over x prime, or dy dt over dx dt. So 1 over 1/2 t to the negative 1/2 is the same thing as 1 over t to the 1/2. So I'm just writing in this form here. I'm going to clean this up though, because dividing by this fraction is the same thing as multiplying by the reciprocal of this fraction. So this is really the same thing as t times 2t to the 1/2 over 1, which turns into 2t to the 3/2. So this is my halfway point, right? This is my dy dx. Think of this as your y prime, right? Um, y prime with respect to x. So now, if I want to find the second derivative, I basically am going to find the derivative of this part divided by dx dt. So I got to take the derivative of this divided by my x prime. So the derivative of my y prime is okay. But we have to remember to also include dx dt. So divided by 1 over 2 or 1 over 2t to the 1/2. Okay, clean this up. This becomes 3t to the 1/2. Divided by this fraction is the same thing as multiplying by the reciprocal. And that gives us 6t. So really the only difficulty with this section is just remembering that, oh, after I find my derivative of my dy dx, I still have to include this dx dt. So this is the part that, um, you know, is the part that that throws students off. Okay. So rest of class here, we'll just do a bunch of practice problems. We're just practicing the concepts of these of finding second derivative. Okay. Y prime over x prime. We can clean this up and make it -4/3 cotangent of t. Second derivative. Derivative of this divided by my dx dt.
He's just sit down. Close the door.
Hi. I should not have worn socks in here.
Oh my god.
Oh, did he's been gallivanting around?
Your job is to sit here.
Okay. Cotangent's derivative is negative cosecant squared t. This is my derivative of dy dx, or my derivative of my y prime. And then don't forget about this dx dt here, divided by -3 sine of t. To clean this up here, I'm going to flip this sign up. Or you can make this cosecant square come down either way. So there's multiple ways to represent this answer here. Okay, number 3. At t equals 1, find the concavity of the graph defined parametrically by x and y. So we associate concavity with second derivative, right? So just go into dy dx. I know it's just going to be y prime divided by x prime. Just going to get to that step here. Y prime, x prime. So I'm going to just split them up into individual fractions so that I don't have to go through quotient rule the next go around. So I'm going to write this as 4t cubed over 3t squared. Okay, so there's my dy dx. My second derivative, I'm just going to find the derivative of that dy dx, and then make sure to divide by my dx dt. So derivative of this, power rule, divided by dx dt, 3t squared. Now, we really don't have to clean this up because we only care about uh, the value here. If it's positive, then we can associate as concave up. If it's negative at this time, then we know we can associate that with concave down. So I'm just going to plug 1 into the second derivative and see what I get. And 2/9 is greater than 0, so we know that at t equals 1, our graph is concave up because our second derivative is positive. Right? Page 9. Find second derivative in terms of t. Y prime over x prime. So our rule for e to the u is e to the u times u prime. And then e to the u times u prime. The 2's cancel out. There's a negative that remains. I can also merge the two bases by subtracting exponents. 2t minus the negative 2t is 4t. You can also think of it as bringing that e to the negative 2t as e to the 2t. And then we can add the exponents. So we get negative 1 e to the 4t. This is my derivative. So d2y. So derivative of my y prime is e to the u times u prime divided by dx dt. So here's my dx dt. -4 and -2 reduces to be 2. I can merge the bases by subtracting exponents, 4t minus a -2t, or e to the 6t. Okay, number 2. Y prime over x prime. Sorry, this reduces to be 4t over 3. Derivative of 4 thirds t is just 4 thirds divided by 3t squared. Same thing as dividing by, multiplying by the reciprocal. Number three, think of A and B as numeric values. Like imagine A was like 4 or imagine B was like 5. We're just going to treat them like constants. Okay. So BT's derivative is just B. Imagine this is 5T, right? 5T will just become 5. So BT would just become B. AT cubed would be 3AT squared. Which if we clean this up, think of A and B as coefficients, and then the T is your variable. So I can write this as B over 3A T to the negative 2, so that I can just rely on power rule for my next step, and rather than have to go through like, force ourselves into quotient rule when we don't have to, especially if there's only one variable in this entire expression. Okay. Derivative, coefficient stays. Derivative, negative 2t to the negative 3. All over my x prime. Let me do some cleanup here. This I can combine to be negative 2b over 3at cubed times the reciprocal of this, because dividing by this is the same thing as multiplying by the reciprocal. So 9a squared t to the 5th. Number 4, they're already providing y prime and x prime. So just copy those values down. So then second derivative would just be the derivative of this divided by my dx dt. So the derivative of sine of u is cosine of u times u prime, coefficient stays, divided by dx dt. So 2 over 4, or 2 over 4 reduced to be 1/2. 1/4 divided by 1/2 is the same thing as 1/4 times 2, which would just be 1/2. I'm sorry, divided by, let me just go through this here, 1/2 t times 1/4. All right, number 5. This one requires a little bit more with our derivative process. That te to the negative t, we have to go through an additional product rule to get the derivative there. So product rule here, f prime g plus f g prime. So product rule here, divided by dx dt. So e to the u's derivative is still e to the u times u prime, or e to the t. There's only one term below, so I prefer to split them up into individual terms, find the derivative to get to my, but let me see if I can clean this up here. Um, if I merge this together, I get e to the negative 2t. If I just want to bring it up together to the numerator, right? Negative t minus a t will be negative 2t. So there's my halfway point. To find the second derivative, I'll just find my derivative of my y prime divided by dx dt. So to find the derivative of this, I got to go through another product rule there. All right, e to the negative 2t becomes e to the negative 2t times negative 2. Minus, I'm going to get myself ready for product rule here, f prime g plus f g prime. So f prime g plus f g prime, e to the negative 2t becomes e to the negative 2t times negative 2 all over e to the t. So that's my dx dt. There's only one term below, so I should be able to split them up into individual fractions and get my second derivative cleaned up. Let's see, these are like terms. It's basically negative 3e to the negative 2t over e to the t. I can just push this negative exponent back down here. So negative 3 over e to the 3t. And then plus and then I can move the negative exponent down here, share the same space as this. I get e to the 3t down below as well. Oh, I lost the -2 here. All right, number 6. Y prime over X prime. Reduces to be 3t. Second derivative. Derivative of my y prime divided by my dx dt. Okay, the homework for this section is just page 10 and 11. I realize that we're not able to quite do the 9.2 AP practice because it requires knowledge about arc length, which we'll cover tomorrow. So I will send you all a text remind this evening or afternoon when we find out what our uh, what's happening for tomorrow. I'm assuming that we're going to be back in school, um, but if we are, then tomorrow we will continue with our lesson, and then or continue with 9.3, and then your quiz will be on Friday. But I will also have help sessions tomorrow morning and Friday morning. But I will send out a confirmation remind text this afternoon, evening, once we know for sure school is back tomorrow. So, but yeah, no homework due tomorrow. If we are back in school, we're just eventually I will check homework, but this may get pushed into next week. I just want to be able to stay up to date with our lesson. That's or with our calendar. Um, that's a priority for me. All right. So we'll cut this class short today. But yeah, I'll send you guys a message later today about status for tomorrow. All right, thanks everyone. Have a great day.